Okay, here we go with another exciting assignment. This is assignment 4.2, so Unit 4, Lesson 2. And what this assignment has to deal with is the relationship that exists between exponents and roots, or radical notation. All right, so there's a few things that we need to cover before we're able to answer really any of these questions. Okay. First and foremost is if something wants something, quote unquote, in exponential notation, exponential, that means it has some sort of power to it. So like x to the 3, or x to the 1/4, or x to the -3, or x to the 2, or something like that. These are all exponents. So if they want something in exponential form, that's the way it should look. If they want something in quote unquote radical form, okay, radicals are like roots of things, square roots, the check mark looking thing. So it could be, like the 5th root of x to the 4th, or it could be the 3rd root of x squared, or it could be the 5th root of x to the 3rd, or something like that. I don't know. So it's written in some sort of radical, aka root form. So there's exponential form, and then there's radical form. Okay, now what is the relationship between these two forms, and how can I kind of seamlessly transition from one to the other? Okay, that's the next logical question. All right, so let's start with roots. Let's start with the radical form. And let's just start off with our basic square root. When there's a square root, there's an invisible 2 right there. As opposed to, you could have a cube root or a 3rd root, which has a 3 on the check. That's fine. How these things are related as an exponent is this. Okay, both of these x's are technically to the 1st power. So both of their answers, both of their exponents are to the 1st power. And the root is a denominator of the exponent. So in this first example, we are talking about a square root, so the denominator is 2. So the bottom, the denominator, is the type of root that it is. The second one, it's a cube root. So it's written as that. All right. Other examples could be, let's say we have an x to the 3rd power. Okay, let's say we have an x to the 3rd power, and it's inside of a 5th root. Okay, not a big deal. The power is still 3, so the exponent is still 3, and the denominator of that is the type of root that it is. Okay. So that is how you transition from a root to a power, or a power back to a root. A couple notes about something. Let's say I have x to the 2/3. Okay, x to the 2/3. All right, this can be written in a couple different ways. So here we have x squared. Okay, we have x squared, and this is on the inside of a 3rd root. So you can legitimately write it like that: x squared to the 3rd root. Okay. Or sometimes people involve parentheses, and so that's where the parentheses are. Another way that this could be written is this. This is the 3rd root of x, and this is to the 2nd power. So sometimes people can put the 2 on the outside. So that's like the 3rd root of x squared, or the 3rd root of x squared. It's the same thing. These two things are 100% the same. And on some of the questions that we'll have to face today, they want both of the answers. Okay, I don't think we need this other piece of paper today. So let's go ahead and just kind of expand this. So it's taking up more of the room. Okay, so here we go. They want us to rewrite this expression in exponential form. So they want this as an exponent. All right, so what I kind of see here is this is the square root of 11 to the 5th power. Okay, so here we go. The number 11, fine and dandy. The power is 5, and the root is 2. And so there it is. That's 11 to the 5 over 2. That's written in exponential notation. Rewrite this in radical notation. Okay, so I see that this is 43 to the 1st power, and this is going to be the 5th root of that. All right, so usually you don't see things written to the 1st power like this, so most often you'll see this as the 5th root of 43. Rewrite this in radical notation. So this is 8 to the 4th power. Excuse me, as you were. Go ahead. Sorry. This is 8 to the 3rd power, and this is the 4th root of that. Now, here is kind of something. So I think this might be the answer of this. It could be written in a couple different ways. All right. So let me go through all of the things that I'm worried about in this problem. All right, so this could be legitimately the answer. Another answer could be this is the 4th root of 8 to the 3rd power. It could be written like that. Here's what I'm super duper kind of scared of. If you think about 8, 8 is the same thing as saying 2 times 2 times 2. All right? So if I have an 8 to the 3rd power, if I have an 8 to the 3rd power, it's 2 times 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 2. Because that would be 8 times 8 times 8. Okay, so that would be technically 8 to the 3rd power. So here's what I'm kind of worried about. So if this is in the 4th root, right? Just like we did in the last assignment, you can make groups of 4. So if you can make groups of 4, they go to the outside. So there's a 2 out, 2 out. That means there's a 4 out, 2 in. So I don't know if they're going to get that tricky, or if you can just leave the answer as what we have here on the left. But either way, we can be prepared for whatever may come. I don't think they're going to get this tricky. But again, I'm not them. I didn't write this assignment. Okay. Write this in exponential form and then simplify. All right, so this is 64. Sorry, let me back up here a little bit. All right, this is 64x to the 3rd to the 1/3. Right, what you can do is you can attach this 1/3 in just like this. So this is 64 to the 1/3. And x to the 3rd to the 1/3. So pow multiply now. 3 times 1/3 is 3/3. All right. So 3/3 is obviously 1. Okay, so 3/3 is obviously 1. That's straight up. Okay, 64 to the 1/3 is the 3rd root. So 64 is the same thing as saying 2 times 2 times 2 times 2 times 2 times 2. I believe that's to the 1/3. Or you can see that the third root of 64 is straight up 8. So long story short, this is going to be 8x.
Mr. Anthony, if you're on campus, please call 6100. Again, Mr. Anthony, if you're on campus, please call 6100. Thank you.
Mr. Anthony. So that's that. Right. So I think the easiest way to attempt this problem is try to recognize this as being the third root of 64. I see that the third root of 64 is 8. It's one of those things that you can kind of immediately look up. If not, you can break it down how I kind of broke it down here. All right, next, rewrite the expression in exponential form and simplify. Okay, so here we have 5x to the third. All right, to this, we have a power of 7 and a root of 9. And so I'm pretty sure that's how the answer is going to look. So if you just put that inside in its own unique parentheses, you can just worry about that in its own right. And I'm almost positive that would be the answer. Okay, rewrite the expression in radical form and then simplify. Okay. I'm going to do this problem two different ways. Okay, one way is kind of difficult, I think, and one way is kind of easy. All right, so let's do it the difficult way, and let's understand what's going on here. So this is going to be 4 to the 4th and a third root. 4 to the 4th and a third root. 4 is the same thing as saying 2 times 2. So this is the same thing as saying 2 times 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 2. So that's 4 to the 4th power. So you got 4 times 4 times 4 times 4. So if I am creating a third root of that, that would be groups of 3. So we got 1, 2, 3, 1, 2, 3. So that's a 2 out, 2 out. So that's a 4 out. And a 2 and 2 in, 4 out, 4 in. That is kind of the difficult way of doing the problem. It's kind of the difficult way of doing the problem. The easy way to do the problem, if you kind of see this happening here, is this. If I have 4 to the 4/3, think about 4/3. 4/3 is the same thing as saying 1 and 1/3. 4/3 is the same thing as saying 1 and 1/3. So if I have 1 and 1/3, what it implies is that is 1 on the out and 1 on the in of a third root. So it's 1 4 out, 1 4 in. That is kind of like the easy way that I think that this problem could be done. Okay, so this next problem is pretty much the same problem, but I'm going to do the easy way first. So 6 to the 3/2. That is the same thing as saying 6 to the 1 and 1/2. Okay, 1 and 1/2. So that means there is 1/6 out and 1/6 in. 1/6 out and 1/6 in. 1/6 out, and this is a square root 1/6 in. That's going to be the answer. Okay, the hard way would be understanding that this is a square root of 6 to the 3rd. 6 is the same thing as saying 2 times 3. So this is going to be 2 times 3 times 2 times 3 times 2 times 3. Rearranging the order of that, that'd be 2 times 2 times 2 times 3 times 3 times 3. So here we make groups of 2. So that's a 2 and a 3 on the out, so 2 and 3 on the out. I'll write it in green here. 2 and 3 on the out, and a leftover 2 and a leftover 3 on the in. Same thing, same sides, multiply. So that's 6 and 6. Again, I'm not telling you what to do. You can choose either method. And if you're still confused by it, you can obviously ask in class. Okay, here we have this big, complicated thing, all to the 1/3 power. So this is touching a parentheses. So what this does, applies to all things on the inside. So this is the same thing as saying 27 to the 1/3. X to the 1/2 to the 1/3. I'll talk about that in just a second. 8 to the 1/3. And y to the 5 to the 1/3. So everything takes that exponent of 1/3, whether it be a number, a letter, or anything. Okay, everything gets that 1/3. Okay, the numbers are usually good numbers. So if you understand, this is the same thing as saying the 3rd root of 27. So if you look that up, that should be the number 3. And the 3rd root of 8 is 2. So you can look that up on that sheet. So far, it's 3 and 2. Okay, those are the numbers. Now let's talk about those exponents. Let's talk about the x and the y. You may recall from last chapter that this is a pow. This is a power, right? Pow. Pow, multiply that. I'm going to spell that. So in essence, this x is 1/2 times 1/3. And so 1 times 1 is 1, 2 times 3 is 6. So this is an x to the 1/6. Similarly, in the denominator, we have 5, or aka 5 over 1, times 1/3. So this is 5 over 3. And again, this might be the answer. I'm not exactly sure how they want their answers written. This might be the answer. If not, this would be the answer right here. So it's 3, and this is the 6th root of x. The denominator is 2, right? 5 over 3 is the same thing as saying 1 and 2/3. So that means there is going to be 1y on the out and 2 y's on the in. So that would be 1y on the out and 2 y's on the in. It might look something like that. Okay, similar idea. So this is 16 to the 1/2, x to the 3rd to the 1/2, y to the 4th, 1/2. Okay, again, usually the numbers are good numbers. So I see that this is the square root of 16. Square root of 16 is 4. Okay, so far so good. 16 is the number 4. Outstanding. The x, how multiply now? The top is 3, the bottom is 2. Y, the top is, so here's what I did. 3, or aka 3 over 1, times 1/2 is 3 over 2. In the denominator, I have 4, aka 4 over 1, times 1/2. So that's 4 over 2, which is straight up the number 2. Okay, so this could be the answer right here. Or I could see that this is the same thing as saying 1 and 1/2. So that's 1x out. Okay, that's 1x out, 1x in. So the other potential answer would be 4, 1x out, 1x in, okay, of the square root, and then y squared on bottom. That could also be a potential answer. And then the last question is kind of figuring out what this y is. So in essence, your answer is going to be x to something. Okay, they call it y. In essence, what the question is asking what is the exponent of the answer. Okay, your answer is going to be x to the something. What is that something? Okay, the best way to understand this is to turn everything into an exponent. So the numerator is to the 4th power, so that's to the 1/4. The bottom x is to the 5th power, but because it's to the 1/4, that'll be to the 5/4. Okay, if you recall from last chapter, a division is the top minus the bottom as far as exponents are concerned. Okay, in the world of exponents, that would be the top minus the bottom. So in this world, that would be 1/4 minus 5/4. So that yields -4/4, aka -1. So this comes out to be x to the -1, aka 1 over x. Okay, but we want this to just be a straight up x kind of answer, because this is ultimately equal to x to the y. So if x to the -1 is equal to x to the y, that implies that y is equal to -1. Check out the answer key that I post along with this. It will have some additional problems. I did the assignment twice, and there were some unique problems that are just a little bit different, similar but a little bit different. So check out the answer key for maybe some additional examples of these problems that might look a little bit different to you, but are still definitely doable. All right, so check out the answer key for more problems.